Hey everyone, this is the follow-up of the video of my welder where I promised I would show the schematic. Well, here it is, and I wanted to show you the front panel that I finished. I remounted all the switches and the knob and the two output connectors. So it's basically just a piece of acrylic, 1/8 inch acrylic, painted white. If it's thicker, these things won't be able to fit. You can use sheet metal, but since I was using one of these weird bits, it's really hard to use them on sheet metal. On acrylic, they go right through it. So that's why I didn't use sheet metal. But well, it's nice anyway. Really like it. So these output connectors, you really want to get them if you're gonna build one, because they're just so easy to use. It goes in and out really easily. You can switch them in and out so easily, and that way you don't have to, carry your cables and stinger flopping around. You can put them in a bag next to you, and then you just stick them in when you have to work. So that's the front panel. Now let's go to the schematic. So this is the schematic. So I'm gonna start. So it runs off of 120 volts, 20 amps. If you use it off of 15 amps, you will probably blow your breaker. Unless you use it like, around there, less than halfway through, or maybe a tiny bit more, you won't blow your breaker, but it's really hard to weld. I mean, it's only like 40 amps at that point, and it's better to just, use it out of a 20 amp breaker. So, the main switch is a double pole single throw switch. And now I'm gonna talk a little bit about the power controller. So this is basically a wavelength modulator. As I said, I saw it in Dan's workshop. You can find it in the internet too. You use two 25 amps SCR. It can be 20 amps, but you always want some rating, some extra rating for security. So, or you can get a dual SKKT module. I mean, there's other modules, but I think that's the best you can get, an SKKT. Those come in different amperages. I have one, and this one that's about, I don't know, 72 amps, I think. So it's more than plenty what I need. I mean, I could even put it in the output and it would work, but it would heat up. So you can get 25 amps, but if you're gonna use individual SCRs, this is a 15 amp SCR. Since it's only 50% it only has a 50% duty cycle each of these. Since it's AC, you only need half of the rating. But anyway, don't get 10 amp SCRs. If you're gonna get up these, if you're gonna get individual SCRs, get the highest amperage you can find. So I think this one's 15 amps. Well, if you are gonna use this, you really gotta get a good heatsink with really good ventilation. So it will cool down. So, here's the weld on off switch. The main switch is on the back. There it is. So the main on off switch. I mean, this is the weld on off switch. It goes in series with the rest, in series and parallel with the rest of the circuitry. That way you don't have to get a high amperage rating switch. You can just use, a 1 amp switch. Won't matter. So, here you can put really any triac. Just a regular triac. It looks like exactly the same as an SCR. It's basically two SCRs together. And then you want to get a 32 volt trigger in diac, like that it triggers at 32 volts. I used a 32 volt, but I think from 32 to 40, maybe 50 volts, it works fine. So well, I used a non-polarized metallized 0.22 microfarads capacitor and a 250K pot. You can actually, experiment with this value, you know, until you get, nice. You can, use the whole circle and not have a huge dead space. This one won't actually go to 0 because I don't know, I like it like that. It will go down to about 20 amps. It's like impossible to weld at minimum power, but it will create a spark. And if I ever want to, transform this into a scratch start TIG, it will come really handy to have this at, 20 amps or lower. But I don't like it to turn off because of the noise of the fans. I can't really tell when the transformers turn on or off, so that's a problem. Well, so this is the dimmer circuit. Well, and then in the last video I said why it didn't blow the breaker, and well, here's why. I used a mini inductor. It's from 60 to 100 watt transformer. I use one about this size. You can compare it with my hand. Any old 12 volt transformers, you can find them in CD players and stuff like that, and radios sometimes. So well, you use one of these and put about 30 turns more or less. I already explained this. If you need more power, you take off turns, and if you want more power, and if you are drawing too much power, too much amperage from your wall, and you're blowing the breaker, you add turns to create a greater resistance. So well, now it goes through the transformers. They have to be from 900 watts to 1100. They can be higher, but you will be wasting a lot of potential of the transformers. You can use them for, like a 220 volt welder that can handle those higher currents, those higher wattages. So if you find a 900 watt one, that will be fine. So well, I used 12 gauge wire on the secondary. I gave about 32 turns on each one, and I got 27 volts in each one. So well, if you want to calculate the voltage in the output, here's the formula. Voltage on the secondary equals voltage on the primary divided by turns on the primary times turns on the secondary. So well, if you want to calculate the specific voltage, you can use this formula. To know the primary turns, you can add 10 turns to the secondary and rearrange the formula to know how much turns there is in the primary with the output voltage and all that. So in the rectifier, I used an MDQ 100 amp. Here I have another one that looks like that. This one's a 200 amp, but it's a little bit smaller, the 100 amp one, but it looks like this. This MDQ 200 amp. I'm using a smaller one, and this you gotta mount it on a heatsink, on a good big heatsink. If you can find fans like this from computers that actually come with a heatsink on it, that would be really good. Then you mount the bridge rectifier on that heatsink. This one's obviously really small, but like here on the back fan, this one has a heatsink on it, and on that heatsink is the bridge rectifier, since it's probably the component that gets the most hot. Although it's rated for higher amperage than this will make, it still gets hot. It's a component that naturally gets hot. So then I had this, then the choke. You can use a smaller transformer. You can use a microwave oven transformer, but I actually found another one on a voltage regulator that was much more better, since it was wattage doesn't, it does matter, but not that much. It is the number of turns. So I found one that looks a little bit like this. So this transformer is actually quite skinny and lightweight, but it's, as you see, it's really tall. They compensate the lightweight and all that with the tallness. So that will let you add so many more turns, and that's great. So if you can find one like that, that would be really good. Well, I found one like that, and that will let me fit about 60 turns. But like 32 turns probably is fine. Probably more, like 40 turns is fine. Well, so if you want to calculate the amperage, if you don't have a clamp meter, I do have one, but I don't trust it. It was like $4 on the internet. So, well, the amperage maximum is equal to wattage total, your transformer wattage total, divided by welding volts. So all you have to do is measure the voltage while you're welding. So somehow when you stick some probes in here and stick your cables too, and measure the voltage. And I got mine drops at about 24 volts. And doing the formula, it gave me 65 amps, since it's 1800 watts. But, well, you always have, it won't be always the maximum since nothing's 100% efficient. So you will always have to subtract a little bit. So if your formula says, it's 80 amps, it's probably only 70. But, well, that's how I calculated the amperage. So it has 54 volts DC current open circuit. And well, that's basically it. Now I'm gonna talk really fast about the ventilation. I just use 24 volt transformer like this one. I used a sender tap one since it's the only one I had, and I used the 12 volt branch, the 12 volt tap out of it to power all 5 fans. But this fan draws about 0.5 amps, and each one of these about 0.2. So it wasn't enough. When I connected all together, each one would slow down. So what I did, I actually took from the 24 volt tap. I used a regulator and some filtering, and I put them in series, 2 of them, and that cut the current in half. And well, then the remaining single fan, I got it out of the 12 volt tap and used another regulator and powered the single fan. This one's the one that draws the most current, so that one's alone. And well, that's basically it. I really recommend doing this. It's a really simple project and it works great, and I mean really it works really well, and as you see it's quite portable. And half of the things, as you see, are recycled. All these come from PCs. The fan in the back. The the transformers were scrapped from microwaves, as you know, and a voltage regulator. The fan transformer was scrapped from a CD player. So, well, you should really try doing one like this. Well, bye.